If you're living in a small flat like me, you might have thought about getting yourself a balcony power station. I have one, but I'm not very happy with it, to say the least. When the sun is hitting the panels, I have a peak power for around 2 or maybe 3 hours, but all that energy is going nowhere. Well, it's actually not true, of course. Of course, it's going into the grid for free, and I don't get nothing from that. And that's the problem. It would be a way better to store this energy in a battery. That's why. Well, and then of course release it gradually, so that I'm not giving it away for free to my energy supplier. So yeah, that's the goal for this video, i.e. basically upgrading my existing power station, well, balcony power station with a battery and also an inverter with an adjustable power output. Let's do it. My balcony power station is a continuous experiment. For the most time it was looking like this, but now I only have one big panel, as you can see right here. On the solar side, more panels would be better, of course. But for the sake of this video, for this upgrade, it actually won't matter. Currently the generated power is going straight into the grid through a grid tie inverter. So now first of all I have to exchange this grid tie inverter with a battery charge controller, of course. And again, adding more panels and more charge controllers won't change the idea of this video too much. You can basically hook up many more panels and charge controllers to these batteries. They can handle way more charge current anyways. So the new plan is, of course, panel, charge controller, into the battery. I have two, but I will of course use them in parallel, so it's just one battery. That's where I will store the generated energy. And then on the battery side, or rather grid side, I will use an inverter with an adjustable power output. As far as I know, my ongoing power consumption is around 60 watts. So for this next system, I will dial in exactly this amount. And now for a bit of math, I have two 12-volt batteries with 100 amp hours. That means a total capacity of 2.4 kilowatt hours. And that means with a constant power output of 60 watts, this setup would last exactly 40 hours, neglecting any losses, of course. In the worst possible scenario, I think it would still last at least a full day, a full 24 hours. And with that, I would actually be extremely happy, because this way I would be able to keep and use all of the produced energy myself. So let's go for it. So here we go. Let's do this first of all. So we have all this info on the sides. Then here we have the front and the back, and the bottom and the top they're just blank. So let's see. So on top we have all the accessories, a divider, and yeah, that's already the battery right here. Quite small and compact. Two handles. The second one. So there we go. So that's the bag, and inside of this bag we will first of all get the activation switch, RJ45 port, and this on-off button. Then also two spare screws right there, and of course the paperwork, stickers, contact addresses, the warranty card, that's the other side, and of course the manual right there. So we have this and this on the other side. So there we have it. So that's the front, of course. That's the side with one of these carrying handles or carrying slots. The back is just blank, and the other side with the other carrying handle. Then the bottom is looking like this. And lastly, we of course have the top, plus and minus, all the specs. And also right here we have the two ports. We have the up and the link port. And the battery is currently in the sleep mode, so to say. And with the on-off button, we can, it's actually active. Really? 2.9 volts. Oh, now, never mind, now it's on. That's way brighter now. So let's check the voltage again. 13.3. All right, so it's super bright, and now 1, 2, 3. And now it's deactivated again in the shelf mode. But of course, I want them to be active. There we have it. And let's do the same for the other battery as well. So again, it's lighting up a bit, you know. But now check this out. That is way brighter. Now it's active. So both of them are activated and ready to go. So here we go. This of course will need a complete overhaul. I just have the panel hooked up to the grid tie inverter and it's plugged into the socket and socket down here. Super simple solution, but not optimal, so let's change that. And these are all the parts that I will use. So I have two more panels that I will hook up in parallel, 200 watts in total, so I'll have another small charge controller for those. The big one for the big panel, this one for the grid tie inverter that you can set up. Of course, all the cables and in between the charge controllers and the grid tie inverter, we of course have the batteries. And also an important safety feature that's not very expensive, an FE switch. So let's do it. So here we go. First of all, check it out, more solar panels down here. This one is cleaned up, 200 watts down there, around 350 watts right here, with the potential to put up two more flexible panels up here maybe. And here we have the wiring. It's pretty chaotic, but it's not that bad. So we of course have the panels going into the charge controllers. It's set to the lithium battery, 12 volts of course. This one is still pumping in power, not too bad. It's like almost 8 p.m. so not a lot of sun left. And from the charge controllers we are going into the battery, into both of them of course. They are hooked up in parallel. My charging side is the front battery, so we have the plus poles and the minus poles going in, and then back here we have the grid tie inverter, and this is connected to the back side, to the back battery. Not that it matters, but just for the organization aspect. And this thing is going into the grid over the safety plug-in right there, and we can just test it right here and reset it. And I've dialed in this one with this power bank. I've just hooked up the car jack, you know, the cigarette lighter, to this, and then this has an output measurement right there, and it's not easy to dial it in perfectly, but it's on the very low side at around 50 to 60 watts of power consumption. So that's the gross, so it will draw 50 to 60 watts from these batteries, so they should last at least 24 hours, and I'm totally fine with that. So yeah, that's the setup, and I'm honestly pretty happy with it. During the summer they can just stay like that, and for the winter I will need to build a little enclosure for them, and thanks to self-heating you can also use them during the winter. Although the generated power is probably not going to be sufficient, I would need way more solar power to power these batteries meaningfully during the winter times. But yeah, the self-heating is definitely a game changer for all year outdoor usage. So yeah, big thumbs up from my side. Awesome batteries, and definitely a massive improvement of my balcony power station. So done with the upgrade, hands down a massive improvement, and with the batteries in place, the whole system just makes way more sense. I will of course list and link all the used components in the description. The inverter and the charge controller are fairly basic and also rather cheap components, but when it gets to the batteries, I went in a bit harder budget-wise, because on this front, especially when it gets to the safety precautions, I want to be on the safe side. So I got batteries from Renogy, an up and coming brand to say the least. If you're into DIY solar builds and such, you will probably already know their affordable high-end LiFePO batteries. And to me, these batteries look very safe while still being budget friendly. Bleeding edge BMS in their many safety features. They can even be monitored over Bluetooth with an additional Bluetooth accessory, you know, with a Bluetooth module. So this is future-proof tech right here, and that is also something that is very important to me. These batteries are grade A pouch cells with over 6,000 lifetime cycles, easily 10 years of lifetime and more. And as I said, they have an incredibly advanced BMS integrated that provides over 20 protections. And aside from that, they're also designed to allow a peak current of 150 amps to pass through, and that's more than enough. That's plenty. Quite insane for this small form factor. And not to forget, a game-changing feature is the intelligent self-heating function that will start operating automatically once the battery's core temperature drops below 5 degrees centigrade or around 41 degrees Fahrenheit. And that is just amazing for me because I'm using them outdoors, as you saw. One thing that I still need to build would be an insulated enclosure for the winter, but thankfully there is a bit of time until then. So let's see how this new system will perform over the next weeks and months. I will make sure to update you in the next solar related video. So yeah, this new upgrade is a definitely drippy, I'd say. Check out the product links in the description if you're interested. But before you go, smash that like button, then subscribe, ring the bell and click all to never miss amazing tech magnet videos. That's it for this one, enjoy it and I will see you soon.